All right, in 5.1, we continue working with our trig identities. In this section, we're going to use our identities to simplify equations. So in simplifying, we are making it smaller. So it gives us a whole bunch of trig identities. So it's on the first slide and on the next one. These trig identities, you guys can have your notes for tests and quizzes. In the past, we've given you the trig identities for the test, so I'm not exactly sure if people on Zoom, I'll probably send out like a page of all of this so you can either print it or make sure you have everything written down. But people in class for the test and quiz, you'll get this on paper. So this will be in front of you for the test and quiz. So when you're doing your homework, you want this to be in front of you the whole time, because you're going to use these trig identities to simplify your equations. So the first little section we have here is our reciprocal identities. We all know these from the last section. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. The reciprocal of tangent is cotangent. So the same thing, sine is the same thing as saying 1 over cosecant. And it applies for all 6 of our trig functions. Every trig function has its reciprocal. Next, we have quotient identities. Tangent is the same thing as sine over cosine. A lot of times when we're simplifying our equations, we want to get everything in terms of sine and cosine. So anytime we would see a tangent or cotangent, it will help to change it to sine over cosine. And cotangent is the opposite, which is cosine over sine. Next, we have our Pythagorean identities. So anytime we see one of our trig functions squared, most of the time we are going to use one of our Pythagorean identities. So sine squared plus cosine squared is equal to 1. 1 plus tangent squared is equal to secant squared, and 1 plus cotangent squared is equal to cosecant squared. So anytime we see one of our trig functions squared, we want to look at these Pythagorean identities to help us simplify. On the next page, we have some more. So we have cofunction identities and even and odd identities. We don't use these too much, but on WebAssign, there's some questions where it'll give you like the sine of pi over 2 minus u, and then you just have to type in that the answer is cosine of u. On WebAssign, just be careful that what you're typing in, it's all lowercase, so that kind of trips people up a little bit. Because for these, you're just typing in the answer, so it just has to be all lowercase. All right, let's look at our first example. So for example 1, we've seen this in chapter 4. So it says use the values of secant u is equal to negative 3 over 2 and tangent u is greater than 0 to find the values of all 6 trig functions. So to find all 6 trig functions, we need to use our x, y, and r. So in terms of x, y, and r, what is sine of u? Anybody remember this from before the break?
Is it y?
It's y, but that's when we're just using x and y, so it's y over r. So sine of u, which sine of u is the same thing as sine of x, sine of theta. It's just a variable there. So sine is y over r. What's cosine?
X over r.
X over r. What's tangent?
Y over x.
y over x. What is cosecant?
R over y.
Awesome, r over y. Secant?
R over x.
R over x. And cotangent?
X over y.
X over y. So here it gives us that secant is negative 3 over 2. So secant we said was r over x, so that means the top is going to be r and the bottom is going to be x. Which one do you think the negative stays with? Does it stay with the r or does it stay with the x?
The r. Oh no, the x.
The x. R is our hypotenuse, and the hypotenuse is always positive. So this is negative 2 is our x. I'll rewrite it over here. So negative 2 is our x, and 3 is our r. So now we just have to find our y. It also tells us that tangent of u is greater than 0, so that we need to use our little acronym that tells us what quadrant it's in. So all students take calculus. If secant is negative, which two quadrants can we cancel out right off the bat?
One and 4.
Right, 1 and 4, because all of them are not positive, and secant goes with cosine, so that means cosine is not positive either. And then tangent of u is greater than 0, so what are we left with here? If tangent is positive, which can we cancel out next? Tangent is positive, so which one can we cancel out?
Quadrant 2.
Quadrant 2, one with sine. So we're just looking at the third quadrant. So that means the only thing that's going to be positive is our tangent and cotangent. So these are the only two that are positive. Everything else is going to be negative. Does anybody remember how we find our y?
You could do like the Pythagorean theorem.
Pythagorean theorem. So remember we said r is our hypotenuse, so that is going to be our c squared. And then we have negative 2 squared plus y squared is equal to 3 squared. All right, so negative 2 squared is 4 plus y squared is equal to 9. Subtract 4 on both sides, so y squared is equal to 5. So what do we get for y?
Square root of 5.
Square root of 5. Now is our square root of 5 positive or negative?
Negative.
Negative, perfect. Because in this quadrant, if we have a point down here, both our x and y are going to be negative. It's to the left and it's down, so our x and y have to be negative. And then once we have our x, r, and y, we just plug everything in. So what's our sine of u going to be? If if we said it's y over r? What's our y? Square root 5. And what's our r? 3. So we have negative square root 5 over 3. So all we're doing is plugging in for this step. Do we need to simplify this? Nope. Only when our square root's on the bottom we have to simplify. So cosine, we have x over r. What's our x? Negative 2. And what's our r?
3.
3. Tangent, we have y over x. What's our y?
Negative square root of 5.
Negative square root 5. What's our x? Negative 2. What does this simplify to? Bless you.
Positive square root of 5 over 2.
Awesome. Positive square root 5 over 2. We knew our tangent had to be positive, so the negatives just end up canceling each other out. All right, cosecant. Cosecant, we just flip signs. So this would give us negative 3 over square root 5. How can we simplify this?
Multiply by the denominator.
Multiply the top and the bottom by square root 5. So what does this give us?
Negative 3 times square root of 5 over 5.
Negative 3 square root 5 over 5. Perfect. All right, secant. What do we get for secant?
Over negative 2.
3 over negative 2, so negative 3 over 2. And then cotangent.
Negative 2 over negative square root of 5.
Perfect. So it becomes positive 2 over square root 5. And how can we simplify this?
Multiply top and bottom by square root of 5.
Awesome. Multiply top and bottom by square root 5. I'm glad Matthew's not asleep today, like the rest of you guys. I get it. It's the first Monday back. I'm tired too. So we get 2 square root 5 over 5. So we've done this in chapter 4. This is not new stuff yet. The next example is new. Any questions on this? Ready for the next one? All right, example 2. So now we are simplifying our trig expressions. So these are the examples that you want to have all of your identities in front of you. So if it helps, screenshot your identities, split screen, whatever you have to do. Have those identities in front of you when solving all of these. Now to simplify these, I'm going to reference algebra quite a bit because that's what we're pretty much using, except we substitute in our trig functions. So for this one, we could say, if sine is our x and cosine is our y, we could say x times y squared minus x. What would I do to simplify this? Do these two things have anything in common? Do these two terms?
They both have x.
They both have an x. So to simplify, we can take out an x, and I'm left with x times y squared minus 1. So we're pretty much doing the same thing here, except instead of x and y's, we just have sines and cosines. So what do I have in common between these two terms?
Sine of x.
Sine of x. So I can take out a sine of x. What am I left with when I take out a sine of x of both of them?
Cosine squared x.
Cosine squared x. What else?
Minus 1.
Minus 1. Perfect. So I'm taking out a sine of x. So I'm dividing both of these by sine of x. So sine of x and sine of x cancel. We're just left with cosine squared x. And then sine of x over sine of x becomes 1. Now I can simplify this more because I see I have that cosine squared of x. Do I have a trig identity that involves cosine squared? Remember, anytime we see squared, we want to look at our Pythagorean identities. So the one that involves cosine is sine squared plus cosine squared is equal to 1. Now my goal is to substitute something in for this cosine. So I want this to be cosine squared of x equals something. So how do I get that cosine squared of x all by itself?
Subtract the sine of x.
Awesome. Subtract sine squared x. So I have cosine squared x is equal to 1 minus sine squared x. So I'm going to take 1 minus sine squared x and plug that in for cosine squared. What can I do next to simplify this?
Subtract the 1.
Subtract the 1. So I have 1 minus 1. These just cancel out. So now I'm left with sine x times negative sine squared x. Now this is just like saying x times negative x squared. What do I get when I multiply x times negative x squared? If I have 1x here and 2x's on the inside, how many do I have?
3.
3. So this would be negative x cubed. So what do you think in our trig problem here, what do you think we get?
Negative sine cubed x.
Awesome. Negative sine cubed x. Any questions on this one? So when simplifying, our goal is to get it down into one trig function, really. Go ahead. Any questions on this? Ready for the next? All right, so example 3, we are factoring each expression. So let's look at A. We have secant squared theta minus 1. So we can say this is x squared minus 1. So I'm just substituting x in for secant. Do we know how to factor x squared minus 1? What does x squared minus 1 factor into?
1, x plus 1.
Awesome. X minus 1, x plus 1. What did we say x is?
Secant.
X is secant. So to change this back into our trig function, I'm just going to plug in secant. So I have secant theta minus 1 times secant theta plus 1. So you don't have to change it into the x if you can see that you can factor this into secant theta minus 1, secant theta plus 1 right off the bat. Sometimes it helps to change your trig functions into x's, just because that takes you back right into algebra 2 and algebra, and you know how to factor this. We just throw in some trig functions to make it pre-calc. Any questions on this one?
I saw that using the Pythagorean identities, you could like change it to tan squared. That's like you would want that for like a different question.
If it
right?
said simplify, we would use that. That would be perfect. But this, it says to factor.
Oh, all right. Thank you.
Any other questions on this one? All right, let's look at B. So we have 4x squared plus x minus 3. So I just changed tangent to be x. What is the first thing I need to do to factor this?
Multiply the first and the last.
Multiply the first and the last. So 4 times negative 3 gives me negative 12. What are my two factors of negative 12 that add to give me 1?
X plus 4, x minus 3.
Perfect. 4 and negative 3. So we have x plus 4, x minus 3. Now we can't forget we started with a number out here that was not 1, so we just need to divide our numbers inside by that number. If it simplifies, we simplify, so this becomes x plus 1. If it does not simplify, it becomes our coefficient. So 4x minus 3. What's the last step we need to do here?
Equal it to 0.
Not equal it to 0. We're just factoring. So I factored, can't factor it anymore. But what did I start out with that I need to change it back to?
Tangent.
Tangent. So I just need to change my x's back to tangent. So I have tangent of theta plus 1 and 4 tangent of theta minus 3. Any questions here? So let's take a look at example 4. So again, we're factoring here. The only difference is we have cosecants and cotangents in this problem. So this would be like saying x squared minus y minus 3. Can we factor this? No. So we want to get all of our trig functions to be the same thing. So what do you think we can do?
Use the Pythagorean identity.
Use one of our Pythagorean identities. So the Pythagorean identity that involves cosecant is 1 plus cotangent squared u is equal to cosecant squared u. So we can substitute this cosecant squared in, well, we can substitute 1 plus cotangent squared in for our cosecant squared. Everybody with me so far?
Wait, so we can't do what we just did for the other one because it's two different.
Right. So we have to make it all the same trig function, which this trig identity is perfect because when we plug this in for our cosecant, it gives us cotangent. So then we're just left with cotangents in our problem. So then it would all be the same trig function and we can factor from there. So let's plug in 1 plus cotangent squared x minus cotangent x minus 3. What can I do to simplify this before I factor? Add like terms. So I have 1 minus 3, which gives me what?
-2.
-2. So cotangent squared x minus cotangent x minus 2. All right. So what can we do next to factor this? We can say that cotangent is x, so we have x squared minus x minus 2. Do we have two factors of -2 that add to -1? What are they?
One times -2.
1 times -2. So this becomes x plus 1 and x minus 2. What's the last thing we need to do?
Switch it back to cotangent.
Switch it back to cotangent. So we have cotangent of x plus 1 times cotangent of x minus 2. Any questions on this one? All right, we're going to do the next two examples tomorrow.